Hello everyone, it's October 26th. Alright. Old problem. As old as it can be. Given S, return the longest palindromic substring. Do you remember how to do this? I don't. I don't remember. I don't remember at all. So I have to just do this from scratch. Is this has one of those smart ideas? I never remember how to use it. Anyway, so we want to find the longest palindromic substring, right? So yeah, remember there's like a ON solution, and the general one was ON squared, something like that. Palindromic, right? So what was it? So longest palindrome. The current being the center? Is that how it is? The current being the center. Nah, I don't. If we do that. Or because the longest palindrome can end at any position, right? So we can say the longest palindrome ending at a certain position, right? The longest palindrome ending at this, the length is 1. Ending at this, how do we know? We need to find ending at this, right? So we have to find an A before, right? We're gonna find an A before. No, we're gonna find the longest palindrome of this, right? And go to see if there's an A. If there is an A, then we can have it. But the longest palindrome of the one in front of you, if it doesn't have an A, maybe there's another palindrome, or like all the palindromes. The longest palindrome. Let me just think. If I say this position, we have to include this to be the longest palindrome, then we'll have a matching, right? We'll have a matching, and inside it is a palindrome. So is this the longest palindrome ending at this thing? Right? Okay, we say if it's not, and there's something more. Okay? We say if there is something more to make this whole thing a palindrome. But here is not the same. Is that possible? Is that possible? That we have a palindrome that will have another palindrome. Not sure. Honestly, I'm not sure. If we have another palindrome, which means this and this, so like these are the same, right? And the longest palindrome ending at this is going to be here. But can we have another palindrome? So what we want to find out is I mean, it might, right? It might. So what do? We'll have to get all the possible palindromes ending at each position. All possible palindromes ending at each position. Well, that's a different story, right? We need to find all possible palindrome ending at each position because I cannot prove, right? So what we need to do is to find all possible palindromes ending at each position. So like, and here it's gonna be an array of the palindrome like here, right? We have, you know, AI, AJ, so we have that much. And for each one, for the new one, I go through every one to see if there is. If there is, we do it. Right? If there is not, we skip. If there is, we do it. Right? Because we have all the palindromes. Yeah, so it has to include this, right? That sounds more likely, and it's O(n) squared, so it will pass. But I'm pretty sure it's not the optimal solution. So in this case, each one is palindrome by itself, so it's going to be 1, right? So now in A, we go through everything, and in front, there's nothing, right? So there's no A in front. So I cannot include this as palindrome, so this is 0. So this will be 1 just by itself. Now this B, we go through this, right? And we find, oh, there is 1. So I have by itself, and I have 0 for this, okay, by itself, or we have B. For this A, we go through this. This is 2, so we go for, oh, that's good. So this one can have 1. Of course, 0, 1, 2, 3. We have 3, and then try to 0, but there's nothing, right? So this B, same thing. We try this 1. Oh, that's a D. Sorry. Right, 1 doesn't match, so that's not. 3, it's this, doesn't match, so this is just going to be 4. Right? So we go through all, and as we go through each one, we will record the maximum. And this one, the maximum is to 1, so it's length is 3. We will also we record a string. Ugh, record a string. How do you get a string? How do you get a substring from Java? Java gets substring. How do you get substring? There's a substring method. Begin and end. Okay, yeah, we can use begin and end. So yeah, we can use that. I think it will work. O(n) squared. But I'm pretty sure there's a better solution. I don't know. I don't remember. Don't remember at all, so I'm not gonna try. Just solve it first and we read the solution. Okay, so my way of doing it, we need to do we need to have everyone. We just need a previous one, right? That's it. We just need a previous one, and yeah, we just need a previous one. So we can say int pre. It's gonna be a pre new int. At the beginning, it's nothing. Oh, that's not the right way. Let's do a list. Right, pre new array list. Okay. So for the first one, we can definitely do, and then we'll have a string res, okay, equal to s star substring. Is that how you do substring? Beginning and right, that's the result. And pre dot add 0. Right, that's for the start. Okay, we set everything up. And what next? What next is for int I equal to 1, I smaller than s dot length, I plus plus. Okay, so we have the current character, right? We have the current character. Now what we need to do is I need to create a new thing, list, right? Integer temp equal to new array list. Okay, then for integer, let's call it j of pre. Okay, we say if always temp.add I, because we can always use itself, right? So we definitely, oh, hold a second. All right, so we are looking. Actually, it depends. We can definitely add myself, right? What we can also do is if it's the same, right? So we can also say if s dot char at I, right? If it's equal to s dot char at I minus 1, then we can say temp dot add I minus 1. That will also work, right? So we have two kind of tricks. Then we'll go through the pre, right? It's everything that makes the pre a palindrome. So we'll do the pre. Then we say if j minus 1 is larger or equal to 0, and s dot char at j minus 1 is equal to s dot char at I, right? If these two are the same, then we say what? We say temp dot add j minus 1, right? So that's a possibility. And then we have to say if from I, right, to j minus 1. So I minus j minus 1. So basically it's a j minus 1 plus 1, right? So we can do this. This would be plus. So this makes it plus 2. So if this is the length, if the length is larger than rest dot length, okay, then we can say rest shall equal to s dot substring from j minus 1 to I plus 1. All right, that's the new thing. So we do that, blah, blah, blah. We go through all the j. Once we're done, we say pre equals to temp. Then we go. And at the end, we'll return res. Okay, let's give this a shot. This is O(n) squared. Let's run it. It works for this one. Does not work for the second one. I thought I checked this, right? If, right, when I'm here, and then I say if it's equal to char at I minus 1, then we'll add I minus 1. Oh, but I didn't check. Okay, that's a fair point. I did not check. Can we check? Oh, can't check them all together. So if if rest dot length, right, is smaller than 2, right, then rest equal to s dot substring I minus 1 to I plus 1. There we go. That's will handle So I think this shall be right. Have you tried only one? Or try with this? I don't know. Just... Man, what happened today? I kept having disconnected. Alright, so this is the O(n) squared solution. 5, right? That's 5, yeah. We're gonna go all the way back, 2018. 2018. That was a long time ago. 5 years. That's when this whole journey first started, 2018. I was very dedicated back then. See, I started with 1, right? I struggled. Did I give up or why not? And I tried it again. And then I still remember where I was. Probably not on that specific day, but I knew the studio I was at and the general situation I had. I mean, I think I was back in school already. Yeah, I was back in school already. It was no, I was not back in school. I think I was back in school in September. So August, I think, is still during the break. Actually, I don't remember. Wait, hold a second. Where was I? Academic-wise. I mean, I quit the job 2017, right? May 2017. So no, I was in school. I was in school. But I didn't do anything in between, right? I was in school. Probably 2017, late 2017. I was in school already. So this is already a year. It's a year after, but it doesn't make any sense. How long did I go to school for? How many semesters? I don't even remember. But well, I was dedicated back then. Look at this. And then I did again 2021 and 2022. I think the same thing. I used a stupid method and there's a smarter method. But anyway, so this is call it DP, right? At each position, at each character, we try the max. We try all the possible palindromes ending at the character right in front of us, right? To check the possible palindromes that end at the current character. One tricky part is that if the current character is equal to its immediate predecessor, that is a palindrome as well. But technically it is O(n) squared, right? It's O(n) squared. It's also why it's not very good performance, like mediocre performance. So what is the good solution? I don't remember. Don't remember at all. I mean, it's no recollection at all. All right, let's take a look. So that's last year, right? 1 year, 4 months ago. My notches algorithm. What the hell? Of course it's not trivial. I think, is this the regular one? Yeah, I think this is the regular one. You have a DP, you have a temp. Yeah. Yeah. And this is the length. Yeah. Yeah. That was the same. So we need to figure this Monachis algorithm. Alrighty. What the hell is this? We have... God, we put... Yeah, I remember this trick, right? So B A B A D. I put this in between, and I put this at the front, this at the end. Then what? So I have a DP, C and R. The hell is C and what the hell is R? So starting from this position, all the way go to this position. I is larger than C plus R. DP I is equal to 0. That might be mean current. I don't know what R is. Is a situation where the palindrome centered on I does not extend beyond C plus R. And C plus R minus I is the situation where the palindrome centered on I extends beyond C plus R. Oh, Manache is, that's the, yeah, I think that's Manache. I have no clue. Yeah, because it's very classics. A classic problem. I think it's I understood back then. I understood, but just by reading this, it still escaped me. I think it's because you have a previous palindrome, so you can use the previous palindrome to kind of extend to further ones. I don't understand what I was saying because I don't know what C and R is. Come on, maybe this helps. This does not. Oh, yes. Oh, center and radius. Thank you very much. I have center and radius. When a palindrome happens inside another palindrome, so you just extend. By the time it gets to the C, Menache's algorithm will have identified the length of every palindrome centered on the letter before the C. At the C, it runs a loop to identify the largest palindrome centered on the C. With that knowledge, everything after the C looks like the reflection of everything before the C. Yes, this reflection idea. The A after the C has the same longest palindrome as the A before the C. So, but that trick speeds up the calculation tremendously. Okay, so this is the center, okay, and radius. So we go from this, okay, all the way to here. I is large, so C I think is the previous center. Okay, C might be the previous center, and R is its radius. So from the center, I go radius, right? Okay, so I have a center, and I go radius. So if the current, dpi, I is larger than the previous range, then we just start from 0. Otherwise, so it's inside, right? So we have a palindrome, okay? This is a palindrome centered on here. This is the center, right? This is the R. And we have an I now is inside this range. And I say dpi is equal to the minimum of dp 2 times c minus I. Oh, what the hell? 2 times c minus I is a situation where the palindrome centered on I. A palindrome center. So there might be a palindrome centered on I, right? Does not extend beyond. So it might extend beyond, or it might just, so if it's inside, right? It does not extend beyond, so it's inside. So if that's the case, then why is 2 times c minus I? I think dp is, yeah, dp is the maximum that we can get at I. So we say, with the palindrome centered on I does not extend beyond, so it's within. And because these are palindromes, so this is the center of the palindrome, right? This is the center of the palindrome. So this and this is the same, which means we have a same this at this position as well, right? We have this the same position as well. How does this help us? Because I want to know what this length is. And we know this is I, okay? This is I. So this is I, okay? And we want to know what this is. And we know there's a copy exactly here, which means there is an I here as well. Can we know what this is? Can we know this? I might be able to calculate this. Hold a second. So I minus c, okay? I minus c shall be the length of everything in between, right? The length of everything in between shall be I minus c. Maybe minus 1. So or do we include I? Let's just say we do not include I, okay? If we do not include I, then this minus 1, right, is everything in between. So that's from here to here, which is the same from here to here, right? From here to here, right? Which means this position, right? This position shall be C, right, minus C minus C. I want to find this index. What does it mean? If you find this index, so what? Yeah, so what? You find this index. I mean, if you think about it, if we have C plus 1 minus this, so C plus 1 minus I plus C, oh shoot, plus 1. I need to go C minus 1. Right, this has to be C minus 1. Then we have 2C minus I. And what is this? Oh, hold a second. Oh, yes, it's a DP. We need to find this index. That's the index we need to find, okay? So we know the distance, right, between this. Okay, so it's C minus the distance minus 1 is that. So C minus I plus C plus 1 minus 1. 2C minus I. Yes. So dp 2C minus 1 minus I is 2C minus 1 is this. So dp this is the length, maximum length of this, which is equal to this. So either that, or if it extends beyond, so it's like this, okay? If it extends beyond, then for 1, it's going to be this length is r, right? That's r plus this plus this. So what are these? So R, hold on, R, if I know this, and this is just R divided by 2. But this is I, right? I minus C, I is here, minus C, right? I minus C is the length of this, including this. So that's the minus 1, okay? So that is the length of this, 2 times of this, plus 1 shall equal to, what is R? It's how many extend beyond, right? So I say this equal to R, right? Now we have a relationship between these, right? We have a relationship between these. Then how do I calculate like this and this? Oh, no, we don't. We do not. This C plus R minus I is this thing. This thing. Yes. This is just because extend beyond this. So what we can do right now is just to use this as the baseline. This is the baseline, right? This is baseline. So C plus R, right? 1, 2, 3. So C plus R is the index of this, minus the index of this, minus I. So index minus index is the length of this thing. Is that right? Is the length. What is dp? Is dp the half? And I mean, dp is the dp is the radius, right? Yeah, that makes sense. It's the radius. This is the radius. So this is the previous radius. This is the current radius. So this is what we start with, right? And then we have the starting point, and then we choose the smaller of the two. And I plus this radius, which is starting from this I go, this is I plus dpi, this is I minus dpi, and then we go out. Right? So every time if they're equal, which, you know, it is equal, right? If they're equal, then we dpi plus 1. So the radius plus 1 until we can't. Now we have dpi plus 1. Now we have to minus 1 because the last one is not equal. So that's why we have this to go on the outside. It's not equal. Then we have minus 1. So that's the dpi. What the hell is this? Oh, this is to the reach. This is the reach. If the current reach is better than the previous reach, we swap them. So once we've done this, at each position, we know its radius. And then we go index and maxed. It should be radius. And then we go through this, blah, blah, blah. We get the max. And once we get the max, the result is going to be index minus this minus 1. When you divide by 2, because of this thing, we have something in between, right? So it's the size is doubled. So this has to minus d minus 1 plus d plus 1. Oh, marvelous. It's a marvelous solution. I am not writing this in Java. It's not worth it. I mean, just this thing, I have no idea how to do in Java. It's like, how? Well, string builder, we can build a string. I guess, yeah, we can build a string. Okay. We build a string. Now, this is something that we can try again. You know, we try again. Manache. We do the Manache. I have a general idea, right? So we can try. Okay. That's it. Right? I think I did all the JavaScript. Now we're trying to handle this. I already forgot. That's good. This is flatten. Okay, what's this? Build array where you find a maximum exactly k comparisons. Oh, you are given 3 integers, n and k. Consider the following algorithm to find the maximum element of an array of positive integers. Oh, it's like going up and down, right? Yeah, I think it's going up and down. Search cost. Every time maximum value is smaller than the current value, we do that, search cost +1. Should build an array which has the following property. Array has exactly n integers, okay? N integers. And we have the maximum value is m. After applying the mentioned algorithm to the search cost is equal to k, right? Equal to k. Number of ways to build. I don't remember. I think I did this maybe at the beginning of this month. Yeah, I did this at the beginning of this month. Don't remember this problem at all. So we need to create an array such that the number of times a bigger value is encountered is only k times, right? Number of times k times. So n equal to 2. Oh, I remember I struggle a lot of this. N equal to 2, so we need to create this two things, right? And m equal to 3, so it's 1 smaller equal to the value smaller equal to 3, and k equal to 1. So k equal to 1 means there's only one time, right? Only one time that a max value is encountered. Is accounted as the first. Yeah, because only one time. Oh, I don't remember. I don't remember at all. Like some of the problem, I still have a vague memory of how the solution is gonna be. That's why I don't have any memory. K comparisons. I don't even remember like the general idea of this. Yeah, I remember this. Oh, I think I was solving this, right? It means you go up and down and up and down. I was saying like this, and this, like we try to find all different properties, and each one will have a different, connotation. I think that's the one, right? That's the one. Dude, how the good solution is not like this. I think the good solution is. Hey, really? Is it that one? No, I don't remember. I don't think so. Nah, probably not this one. I don't think it's this one. This is to find out how many ways you can create this array, right? Array of size, and it's restricted from 1 to m. And we have a search cost each time a bigger value is encountered. Yeah, so we can only encounter big value k times. And after the k times, we're done. Right? and the max value is actually increasing. So we're saying there shall be k positions, right? K positions in this. K is smaller or equal to n, right? There should be k positions in it where we have just, right, this is the k positions, and each one has to be larger than the previous one. This is like k equal to 4, right? K equal to 4, we need to have 4. And in between shall be a smaller value, right? In between shall be smaller value. And the first one is always the starting position. The starting position always the one, the first one. Hold a second. Hello? Wait, and if I remember correctly, you need to go like to the top to get Uber, and then yeah, I think there are guidelines inside the terminal to guide you to a specific location for Uber pickup. Did you? I think the sign just says ride sharing or something like that. Like I think it says ride sharing. There are signs inside the terminal says ride sharing, and then there's an arrow. So you just follow the arrow. You have to go up. Like the pickup location for Uber is up. It's not. Ride app. Yes. Maybe it's called ride app. So you follow that, and you will go to 2 or 3 specific positions, and then from there you call Uber, and then you will see on your phone where it's going to be. Oh, I didn't realize. I thought you will see the right app. Sorry, I didn't realize that at all. Should have told you. Bye. Wait, you still there? Okay, bye. All right, let's get back to this. So yeah, we say this is the starting position, and it has to be another, bigger than it. So we can, always find the smallest one, put at the front. So it's like, how many different ways we can pick 4 unique, right, numbers out of the given m, right? We're given m values. So it's like m values, choose 4, m choose k, right? M choose k. And then once I do m choose k, then they will have a certain order, okay? And within each can have a lot of different ways of doing it, right? If you do m choose k, you have that many ways to choose them. And between the first pair, now what you cannot do is you can only use the values in between these, right? You can only use the values in between these two. And if you use the value in between these two to fit in here, but how many can we have? Well, we can have a lot of different ways, because we can have these three just right next to each other. So this will fill in the remainder. And then in between these two, you have a number of values in between these two. And in fact, a way that you set up, it cannot include this one, but it can include this one, right? So you have so many spots, and you have so many values. So how many different ways you can organize them? Well, it's a lot. I don't think this is the right way to go. I don't remember. I don't remember at all. Wait, no, it's not in between. It has to be smaller than this. Smaller or equal to this. It's not in between. They cannot have in between. If it's in between, it's gonna be bigger than this. No, it's smaller than this, right? So I have some value smaller than this, and then they need to fit into this, right? If it's only one value, which is all of them, right? Just all of them. And if I have two values, but once you fill out this, what's gonna happen between these two? Or anything that's smaller than this can be filled in these two, right? So basically, what we're saying is, if we have two values, right? Call it A1, A2, okay? A1, A2. A1 is smaller than A2, and then there I have, let's say, B number in between. And we can only use value 1 smaller or equal to x smaller or equal to A1 to fill into this. How many different ways? If we can find that, then yeah, then there's still a problem, like how do we arrange these? Right? How do we arrange these? But that's a less And then if B is smaller, yeah, then B compared to that, right? If B is a lot, then we'll have repeats. But how do we handle repeats? Okay, B is 1, then just every 1, right? And B is 2, can we like DP this? If we know B minus 1, like how many different ways we can fit B minus 1. Okay, so like we have how many ways we can fit B minus 1 on this, we know. Now we need to have one more spot, right? So there's one more spot, because I have all different combinations, okay? All different combinations is already there. Now I have this new spot. Okay, I have this new spot. And have all those choices. if everything ending at a certain value, okay, we have all of them, and for that, ending at this, we just add. We can add it because we end at this, right? This is all unique ones. Then we can add all of them, right? And then we can swap to the other, add, right? Swap to the other, add. They can all do that. Is that right? And then just everybody times the last one. We have 4 different choices. So for each one we have 4 choices. For each one we just times that. Maybe. Maybe. I really have no idea. I mean, in this case, right? N equal to 2. Okay? N equal to 2, K equal to 1. So M is 3. Choose 1. Equal to 3. So we only have 3 ways to set up, which is, just 1, 2, 3. Only 3 ways to set up. And once we've done that, and because there's only 1, we don't have a next one, right? So it's just 1 towards the end, and it's just everything smaller equal to 1, which only have 1 spot. When it's just 1, this will be 2, this will be 3, so that's actually would be 6. But like if we have 4, right, these 2, we know how many this can be, right? We know how many this can be. We know like if this is equal to some certain value, but then this can have a different value. This can, like, they can all have different values. Ugh. And each one will be different. Yeah, I don't think it's working. All right, I have to look at the hints. Is that the one? I don't remember. DPABC is the number of ways you can start building the array, starting from index A, where the search cost C. Maximum. No. Hold on. Is that the one? All right. DP index previous max used, remaining max used. DP index. I'm at the index and I have a previous max used and remaining max to use, remaining number of max to use. So I have previous max used. Hold a second. DP. Okay. index pre-max remaining maxes. So what's the solution? All right. Index previous max and remaining max. How many max remaining? What is the option for the current index? So it has a previous max. So it can either be any value no bigger than the previous max. True. Or it can be one of the new max. True. Right? True. So is this DP is giving me all the ways, right? All the ways. So we are at index with previous maximum. I have the previous maximum. And then with remaining max. I don't even know what's the final. I have the previous max. So I know all the previous. So now I'm at the current index. I can do the current one if I am the same as previous max. Right? What is the maximum number? What is the number of arrays I can produce given that the index? So if I am the previous max, then what? I am the previous max. A number of arrays I can produce. I still don't know. The thing is, I don't know what does it mean. Okay. I think it's start. Start from, what's the first? Start from 0. Previous max is 0. Ah, it's not ending at, it's the starting. Okay, so this is the starting index. Then it makes sense. It can be dp0 because we have to go for 1, so it'll be 0. And this is m. No. Remaining max is k. Right? This is what we want. Yes. All right. So at each position, right? At each position, we want to know is, given the previous max, given the number remaining, starting from the current index going down, what is the number of arrays I can make? So if I pick the same as the previous max, so that's going to be dp index plus 1, right? Pre-max and the remaining max. Doesn't change because I use the same as the previous max, which means the previous max doesn't change and the remaining max doesn't change. Right? That's one possibility. And the other possibility is I use one of the remaining max. Then I will go through everybody, pick one of them, and then we do dpi index plus 1 with a new max, right? With a current, and then we remaining minus 1. And this has to be a loop something. Oh, it doesn't have to be. Previous max is just previous max plus 1. Previous max plus 1 plus 2 plus 3. Doesn't matter. And then, what's the edge case? Well, the edge case of course, this max cannot be larger than m. And if remaining is 0, remaining max is 0. We don't have any more max. Then it's going to be factorial, right? It's going to be factorial. If remaining number is 0, it's going to be factorial. Or if index get out, it's going to be 0. how it is. Shoot. It's not right. It's if I is equal to n, which is we get out, it's either 0 or if we still have remaining max to use, that's 0. If we don't have remaining max, we use everything, that's 1. Makes sense. If remaining is smaller than 0, yeah, remaining cannot be smaller than 0. No bigger than previous max. No bigger than previous max, the current value. So it's going to be this plus 1, P and R. But what is this? Oh, because you can have P different choices. That's the P different choices. Or you go through everybody. Yes, that's from P plus 1 all the way to this. Yes. We're going to do this. Yes, and return. Oh. Dude. What's this? Oh, it's a top down. And this is all right. Oh, it's bad. I need to put this in nightmare. Yeah, this is nightmare. Let's do it again. We have to do it again. Index. So what's the DP again? DP is starting from index, right? Given the previous max value and the number of max we need the remaining. What is the total number? We'll try it again. We'll try it again. I don't think I will even attempt again the fastest way. I'll just, leave it. If I can get the DP done all by myself, that's, good already. All right, this one I still remember how to do. It's not that hard. So we'll deal with this tomorrow. Yeah, I'll have to do this one again. Damn. All right, I'll see you guys tomorrow. Adios.